So hello to all. In our third part of our video, we will proceed with the subtopic of 9.2 Rules of Differentiation. Basically, for this subtopic, most of it would be a recap session of what you have learned before, where you will learn on how to apply the rules of differentiation and perform second and third order of differentiation. Okay, so for 9.2 rules of differentiation, basically we have few rules that you can follow. First one, we call that as a basic rule. For this basic rule, first one, whenever we have a constant as our function, the derivative of it would be a 0, no doubt about it. Okay, second one, whenever we have x to the power of n, where in this case x is your variable and n would be your power, the rules would be bring your power to the front and then your whole power would be minus 1. That's how we get n x to the power of n minus 1. Okay, next one for the third part, whenever we have a k in front of your equation, where k in this case are constant, so you just follow the same rule. So basically bring your power to the front and all power minus 1. That's how we get k and x to the power of n minus 1. So for summation rule, basically there's no changes in your equation. You can differentiate it one by one. So if you have, let's say, ux plus or minus with vx, the derivative of it would be u prime of x plus or minus v prime of x. But different case will happen if we have a multiplication of two different functions. For this one, we have to use product rule, and the rule would be uv prime plus vu prime. And last one, for our rule, whenever we have division of two different functions, our rule we call as a quotient rule, which is vu prime minus with uv prime divided by v squared. Next one, we have a power rule. Power rule we will use whenever we have a higher order of power. Let's say whenever you have to the power of 5 or to the power of 10. Following the rule of basic differentiation, you will bring your power to the front, but for this time, the function inside the bracket, you have to copy it back, and then all power minus 1 times with the derivative of your function, what's left inside the bracket before. And last one, we have chain rule. Basically, we're going to use chain rule whenever we encounter three different variables. So let's do some example to check our understanding. So this is basically a recap session. That's why we use a very simple function. So for the first question, example 5, find the derivatives of the following function. Part A, we have y equal to x cubed. So the derivative of y would be, you can use either y prime or dy dx. In this case here, I will use y prime equal to, following our basic rule, whenever you have a power, you can bring the power to the front and all power would be minus 1. So in this case, you will get 3x squared as your final answer. Okay, part B, we have y equal to 5x to the power of 9. Following the same rule, 5 here is basically just a constant. It does not affect your basic rule. So bring your power to the front and then all power minus 1. So our y prime here would be 5 times with 9 times with x to the power of 8. And your final answer here would be 45x to the power of 8. Next one, part C, we have y equal to third x. And bear in mind, if you confuse here, just change the third form into the power form. So basically, our question here would be x to the power of half. Don't be afraid with the fraction power. Just following the same rule, here our y prime would be half times with x, and then all power minus 1. In this case, we're gonna get negative half. And you can simplify your final answer in a simplest form. So our final answer here will be 1 over 2 third x. Okay, moving on. Question D, we have y equal to x to the power of 3 over 2. So following the same rule, still, bring your power to the front, all power minus 1. So in this case, our y prime would be equal to 3 over 2 x to the power of 3 over 2 minus 1. In this case would be half. So our final answer here would be 3 over 2 third x. Proceed with next one. Question E, we have y equal to 1 over x cubed minus 2. Don't be afraid with the fraction. You just have to change the question into a power form. So this actually can be transformed into x to the power of negative 3 minus 2. So now we can differentiate our equation. So derivative of y, so in this case I use a different symbol. Previously I used a y prime, so now I can use dy over dx will be equal to, so bring your power to the front and then all power minus 1, we're gonna get negative 3 x to the power of negative 4 minus with derivative of 2, in this case would be 0. So your final answer here would be negative 3 over x to the power of 4. Proceed next. Question F, we have y equal to 15 over third x. And in this case, we can rewrite the question as 15 times with x to the power of negative half. So the derivative of this, our dy dx will be equal to, so following once again the same rule, bring your power to the front, all power minus 1, we will have 15 times with negative half times with x to the power of negative 3 over 2. So our final answer here would be negative 15 divided by 2x to the power of 3 over 2. So all this up until question F, we just answer the basic rule. Proceed with question G. We have y equal to 3x squared plus 7 times with 6 minus 5x. Obviously here you can detect this is basically multiplication of two different functions. Whenever we have this type of question, we have to use product rule. So you can let the first function as your u and the second function as your v. I rewrite back our rule. So if we have to use the product rule, our dy dx here would be uv prime plus with vu prime. So in this case, our u is 3x squared plus 7. So our u prime would be 6x. And since our v is 6 minus 5x, our v prime here would be negative 5. Now you just have to substitute back all the u prime and v prime into the formula. So our dy dx here will be equal to uv prime, so 3x squared plus 7 times with negative 5 plus our vu prime, so 6 minus 5x times with 6x. Obviously, you cannot leave your final answer like this, so you have to simplify. Open up all the bracket, we're gonna get negative 15x squared minus 35 plus 36x minus 30x squared. Simplify once again, we're gonna get negative 45x squared plus 36x minus 35, and that would be our final answer. Proceed next. For question H, we have y equal to 2 over x plus 1 times with 1 over x squared minus 3. Even though we have a fraction here, it's still a multiplication of two different functions, so we still have to use the product rule. So to avoid any confusion, I just rewrite back our question in a power form. So this is basically y equal to 2x to the power of negative 1 plus 1 times with x to the power of negative 2 minus 3. So I let the first bracket as u and our second bracket as v. So u prime here would be negative 2 x to the power of negative 2. We can rewrite this as negative 2 over x squared. And our v prime here would be negative 2 to the times x to the power of negative 3. I will rewrite as negative 2 over x cubed. Following our product rule, so our dy dx is basically equal to uv prime plus vu prime. I will substitute one by one. So first one, our u here would be 2 over x plus 1 times with our v prime here would be negative 2 over x cubed, plus with next one, our v here in this case is 1 over x squared minus 3, and last part, our u prime here is negative 2 over x squared. And we can simplify this out, so we will get negative 4 over x to the power of 4 minus 2 over x cubed minus 2 over x to the power of 4 plus 6 over x squared. Since we have a same denominator with x to the power of 4, we can simplify this once again. So your final answer would be negative 6 over x to the power of 4 minus 2 over x cubed plus 6 over x squared. If you already master the skill of basic rules, so you won't have any other problem to solve this question. Proceed next, question I. Now we have y equal to x squared minus 3 over x squared plus 5. So now instead of multiplication, we have a division of two different functions. For numerator part, we can name this as our u, and for denominator part, we name this as our v. So our u prime here will be equal to 2x, and our v prime will be equal also to 2x. I just rewrite back the formula of quotient rule. So our y prime will be equal to vu prime minus uv prime divided by v squared. Be careful, don't mess up with the formula. So here our y prime or our dy dx would be equal to v, so x squared plus 5, u prime here would be 2x minus with u, so x squared minus 3, times with v prime, so we have another 2x there, divided by v squared, so we have x squared plus 5, the whole thing would be squared. So obviously you cannot do anything with the denominator part, but you can simplify the numerator part. So this will be equal to 2x cubed plus 10x minus 2x cubed plus 6x divided by x squared plus 5, the whole thing will be squared. And once again, you can simplify the numerator part, so this will be equal to 16x, because you already can cancel out 2x cubed, divided by x squared plus 5, the whole thing squared. So proceed with question J. We have y equal to 2x cubed plus 1 divided by 3 minus x. So now for this question, we have division of two different functions. So we have to use the quotient rule. For denominator part, we denoted as v, and for numerator part, we will denote this as u. So differentiate each of them first. So u prime here would be 6x squared, and then v prime in this case would be -1. So I just rewrite back our quotient rule formula. Y prime would be equal to vu prime minus with uv prime divided by v squared. Now we will substitute one by one into the formula. So our y prime, or you can use dy dx, will be equal to v, so 3 minus x, times with u prime, so 6x squared, minus with u, so 2x cubed plus 1, minus with, times with -1. So the whole thing would be divided by v squared. So we will have 3 minus x squared. So now we can simplify this. So we will have 18x squared minus 6x cubed plus with 2x cubed plus 1. The whole thing divided by the same thing, 3 minus x squared. And last part, we can simplify for final answer. So our final answer would be 18x squared minus 4x cubed plus 1 divided by 3 minus x, the whole thing squared. And that would be your final answer. Now proceed with example 6. We have to differentiate the following with respect to x, still under the same subtopic, rule of differentiation. Part A, we have y equal to x squared plus 1. The whole thing is to the power of 4. So we can detect here we have a high order of degree of a function. So from here we know that we can use a power rule. So I just copy back, rewrite back the power rule formula. So the derivative of it would be, you have to bring your power to the front, copy back your original function inside the bracket, then all power minus 1 times with the derivative of your function. So following this rule for question A, our dy dx or y prime will be equal to, bring our power to the front, so 4 times with everything inside the bracket. You just have to copy it back, so x squared plus 1, and then all power minus 1, so 4 minus 1, and now you have to differentiate what's inside the bracket. So x squared plus 1, if we differentiate this, we can get 2x. And last part, you just have to simplify your final answer. So in this case, our final answer would be 8x times with x squared plus 1, the whole thing to the power of 3. Easy, right? So practice once again with question B. We have y equal to 1 over surd of 5 minus 2x squared. Okay, since we have a surd here, if I change it into a power form, we will get 5 minus 2x squared to the power of -half. So following our power rule, make sure you bring your power to the front, all power minus 1, and then differentiate in what's inside the bracket. So our dy dx now here will be -half times with 5 minus 2x squared, power minus 1, so we will have -half minus 1. Now we have to differentiate what's inside the bracket. So 5 minus 2x squared, if we differentiate this, we're gonna get -4x. So simplify this, we will get positive 4x divided by 2. And then times with 5 minus 2x squared to the power of -3 over 2. And then once again simplify your final answer, you will get 2x divided by 5 minus 2x squared to the power of 3 over 2. Okay, proceed next for higher order derivative. For first derivative, as we discussed before, we can use the symbol of y prime. you can use the symbol of f prime, or you can use the symbol of dy dx. Second derivative means that you have to differentiate what you have differentiate for first derivative. So we can use the symbol of y double prime, or f double prime, or d squared y over dx squared. And then for the third derivative, basically you just have to differentiate your second derivative. So you can use the symbol of y triple prime, f triple prime, or d cube y over dx cube, and the list would be goes on. Let's practice with example 7. So find the first and all higher order derivative of px equal to negative 2x to the power of 4 plus 9x cubed minus 5x squared plus 7. So for first derivative means that we differentiate it once, so we can use the symbol of p prime x. So differentiate this, we're gonna get negative 8x cubed plus 27x squared minus 10x. And that's it, because basically for the last term, if we differentiate 7, you're gonna get 0. And that's gonna be our first derivative. Okay, moving on. For second derivative, we can use the symbol of p double prime. So differentiate your first derivative, we're gonna get negative 24x squared plus 54x minus 10. And then for third derivative, we're gonna use the symbol of p triple prime. So negative 48x plus 54. Next one, we differentiate it for the fourth time. We're gonna get negative 48. And last one, differentiate it once again for the fifth time. You're gonna get the answer of 0, and that would be the maximum order of derivative for px, because whenever you differentiate 0, you're gonna get once again 0 as your answer.